My main area of research interest is numerical analysis, which is really the mathematics of how computers work. Well, let's take a real-world example to think about. So we might look at how somebody might design a motor racing car. And to do that, what you want to know is how does the air flow across the body of the vehicle. And so what you need is a massive computer that can actually solve this system of equations, because in the end you might need to break down the surface of the car into 1 million pieces in order to represent each of those pieces well enough. Well, you can imagine then you need a very big computer and a very fast way of solving it in order to actually get some sort of answer that means anything inside a reasonable amount of time. Well, my first real spark, I think, in maths was when one of my school teachers, my sixth form school teacher, showed me how many panels are there on a football which are pentagonal. So that was the question, and the interesting answer is it's always 12, and it doesn't matter how many hexagonal panels, because a football is made up of hexagons and pentagons. It doesn't matter how many hexagons you have, but you have to have 12 pentagons. Now, from my point of view, it's some weird miracle that you should be able to say such a thing. It looks like a complicated sort of problem, and then you get out a few equations, right? And there's something called the Euler characteristic of a surface. So we have that, and then we just count. Well, how many? If I've got this number of pentagons and hexagons, how many edges must my thing have? How many vertices? Points where edges intersect. How many of those must I have? I know how many faces I've got. Then I turn it into this. I put it into this Euler characteristic, and out pops the number. P equals the number of pentagons equals 12. And I'll think, wow, look at that. Now I've got to go and try and show that that is true. You know, so that's the job of the mathematician, really. Once you see something, is it true or not? And we try and prove it's true.